Welcome to The Explainer. Today, we are totally flipping the script on how we view AI. Look, we hear this godlike myth all the time, right? Well, it turns out it's actually much more accurate to look at artificial intelligence as a massive industrial brick factory. We're going to dive into a fundamental shift in how we architect digital truth and really contrast the raw, probabilistic guesswork of AI with the rigid, perfectly exact execution of digital agents.
Here is our roadmap for today. We're covering artisanal bricks to AI factories, the flaw of the furnace, the agent is the house, building the semiotic bridge, and finally, the agentic economy. Okay, let's jump right in.
Section 1. Artisanal bricks to AI factories. To really understand where we're going, we have to look at how we used to build our digital architecture. Pre-AI, we essentially built for the rich. And why is that? Because our data bricks were baked entirely by hand. We're talking literal sweat of the brow. Every single line of code, every pixel, every dataset required intense manual human friction. It was slow and expensive. But today, AI has completely changed the game. It acts exactly like Gutenberg's movable type. It's an industrial furnace churning out automated, raw, probabilistic bricks at an absolutely unprecedented scale. We've shifted from artisanal, exact manual labor to this massive, continuous generation of data.
Section 2. The flaw of the furnace. Now, as amazing as that industrial scale is, there is a massive hidden catch inside the hardware. Think about this number for a second. 80 to 90%. That is the staggering percentage of modern AI compute cycles that are actually just hardware-level approximations. When these massive language models do their heavy lifting, they aren't actually delivering an exact mathematical truth. They are fundamentally just guessing the nearest mathematical answer so they can churn through oceans of data at breakneck speeds.
This whole divide actually lives deep inside the physical brain of the computer. On one side, we've got the floating point unit, or what we can call the FPU gambler. It's incredibly fast, sure, but it relies on completely secret proprietary seed tables burned deep into the silicon just to guess the math. On the flip side, we have the arithmetic logic unit, the ALU surveyor. This little component deals strictly in 100% exact deterministic hardware truths. 1 plus 1 is exactly 2 every single time. But right now, to get that insane speed, modern AI is leaning almost entirely on the wildly guessing gambler.
So, here is the absolute crux of the issue. By relying on that FPU gambler, we introduce something called mantissa inaccuracy. Basically, the AI is dropping tiny fractions, like just tossing out the 23rd bit to make the numbers fit the format, which causes microscopic rounding errors. Listen closely to this. When we replace a deterministic agent with this probabilistic AI, we are quite literally replacing a digital, exact method with an analog, lossy method. Over millions and millions of concurrent cycles, those tiny, imperceptible rounding errors compound into massive hallucinations.
And all of this lossy math leads to what industry experts call the wood chipper effect. When non-deterministic hardware just guesses the math, the exact path of that data, its actual provenance, is permanently destroyed. It acts like a giant blender. You might know exactly what fruits you put into it, but there's absolutely no way you can reverse engineer that digital smoothie back into its original individual pieces. You simply cannot build verifiable digital trust on a foundation that is fundamentally just guessing.
Which brings us perfectly to Section 3. The agent is the house.
If the probabilistic AI furnace is just baking these raw, lossy bricks, we desperately need a deterministic architect to actually construct something safe out of them. And here's the fundamental distinction we absolutely have to realize. The AI is not the house. AI just bakes the bricks. The agent is the deterministic house that those bricks built. The digital agent operates on a rigid digital text layer that takes all that chaotic statistical AI output and forces it into verifiable reality. Without the agent, you don't have a structure. You just have a giant, unpredictable pile of bricks.
Section 4. Building the semiotic bridge. So, how do we actually enforce this? How do we connect our messy, abstract human imagination to the freezing cold, rigid physics of a microchip? We construct what's called a semiotic bridge. Step 1 is our human intent, which is naturally warm and associative. Step 2 is where the magic really happens. Strictly formatted text. Think JSON or a command line interface. This text acts as the ultimate deterministic lock, squeezing our boundless imagination into a rigid template. This text is the structural house. Then step 3 is the hardware execution. where that exact deterministic ALU surveyor we talked about executes the text flawlessly.
But guys, this bridge absolutely requires your effort. As the architecture documentation perfectly puts it, manual authorship overrides automated miasma. You literally cannot automate human intent. If you want to build verifiable digital trust, you have to be the sovereign pirate. You cannot just lazily accept the AI's first output. You have to actively prune the text, apply the sweat of your brow, and completely reject the random distortion and guesswork of the AI.
Section 5. The Agentic Economy. Let's look at how all this architecture translates into the real world. Once you have deterministic agents running on exact text, they can actually start interacting with physical reality. And this entirely new economic scale is powered by a fascinating piece of internet history. Back in 1996, the pioneers of the web reserved the HTTP 402 payment required status code specifically for native web transactions. But get this, it literally sat dormant for nearly 30 years. It wasn't until 2025 that the open-source L402 protocol arrived to breathe life back into it, combining Lightning Network micropayments with HTTP authentication.
So how does L402 actually pull this off? Well, traditional web payments are stuck behind a wall of what's called Ricardian complexity. We're talking heavy legal bloat, centralized fiat banks, endless subscriptions, and tons of human friction. L402 completely bypasses all of that with a surgical, lightweight, chopsticks design. Instead of bloated smart contracts, it pairs Lightning Network invoices with lightweight authorization tokens playfully called macaroons. This setup allows our deterministic agents to transact natively, machine to machine, without any human billing departments getting in the way.
In this new agent-to-agent economy, your autonomous agents pay per request in fractions of a cent called satoshis, maybe 5 sats for an AI inference call or 10 sats for a data oracle query, 0 fiat rails involved, and because we are using perfectly exact deterministic LIFO JSON state trees, where the last item to go in is always the first one out, we get complete bit-perfect mathematical proof of the system's state. This absolute exactness is what finally allows agents to confidently command physical robotic action, like triggering the microhost of a cheerbot to spin a motor right there in your living room.
Bringing it all together, we're looking at a beautifully structured ecosystem here. The AI swarm acts as the furnace, continually churning out those raw, probabilistic bricks. The deterministic agent steps up as the rigid foundation, the house the bricks built. And you, the human orchestrator, you sit firmly at the center, actively providing the creative intent and the legal mandate that makes it all run.
As we navigate this incredibly saturated, fast-moving, agentic era, the only provocative question left to ask yourself is this. Will you succumb to the cloud, blindly trusting the probabilistic casino and remaining just another digital tenant? Or will you grasp the command line, apply the sweat of your brow, and ride as the sovereign orchestrator of the deterministic machine? The choice of how we build our future infrastructure is entirely up to you. Thanks so much for joining me on this explainer today. Keep learning, and I will catch you next time.